Bismillahirrahmanirrahim. So today we start the crystallography. As heterogeneous catalyst of solids, crystallography, that is the crystallinity of the solids. So as heterogeneous catalyst, they are solid in nature, solids catalyst. So solids can be of two types. All the heterogeneous catalysts are crystalline in nature. So solids can be classified into two types. One is crystalline solids and non-crystalline solids. So what are crystalline solids? These are the solids in which the structural units are arranged in definite pattern. These are solids in which structural units that can be atoms, ions, or molecules are arranged in definite pattern. Are arranged in definite pattern and giving rise are definite geometrical configurations, giving a definite geometrical configurations are called crystalline solids. Crystalline solids are those solids in which the structural units can be atoms, ions, or molecules. So these structural units are arranged in definite pattern, and this definite arrangement of the structural units give rise to a definite geometrical configurations. So such type of crystalline solids are called crystalline solids. दूसरी तरफ नॉन क्रिस्टलाइन है जिसको एमॉर्फस भी कह सकते हैं, एमॉर्फस सॉलिड्स. ये कौन से हैं? These are the substances having no definite geometrical form. These are solids having no definite geometrical form or no definite pattern. Are regular structures, no definite regular structure. Those are called amorphous. Solids can be classified into crystalline and non-crystalline. Crystalline substances are those substances in which the structural units are arranged in a definite pattern. This arrangement gives rise to a definite geometrical configurations. On the other hand, the amorphous substances or amorphous solids are those solids which have no definite geometrical form. इन दोनों में कुछ differences हैं. Amorphous substances melt. These amorphous substances melt over a wide range of temperature, while crystalline substances melt at a fixed and constant temperature. दोनों में एक ये डिफरेंस है. Amorphous substances melt over a range of temperature. Melting point is over a range of temperature. For crystalline substances, the melting point is fixed and constant. Similarly, amorphous substances possess same value of properties. Amorphous substances possess same value of any property measured in all directions. Measured in all directions. On the other hand, and this property is called isotropic. Isotropy. And substances are isotropic substances. So amorphous substances are isotropic. Means these substances possess same value of any property measured in all directions. For example, refractive index है, thermal conductivity है, electrical conductivity है. Refractive index and electrical conductance, thermal conductance, they have same properties in any directions for amorphous substances. Crystalline के लिए क्या होगा? For crystalline substances and crystalline lead substances, the magnitude of property depends on the magnitude of property depends on directions. Along which it is measured. So this property is called anisotropy. Anisotropy or anisotropic substances. So crystalline substances are anisotropic, while amorphous substances are isotropic. So these properties depends on the direction in which they are measured. कुछ characteristics सेम भी हैं. Amorphous and crystalline substances, some amorphous substances have some characteristics similar to crystallines. उनमें से कौन से हैं? For example, definite shape, इसी तरह rigidity, and hardness. These are similar characteristics as that of the crystallines. However, they do not have regular internal structures. However, these substances do not have regular internal structures. Hence, amorphous substances are not considered as true solids. So, on the basis of this discussions, amorphous substances are considered as not true solids. Not true solids. They are considered as super cold liquid. Amorphous substances, for example, glass and polymers of high molecular weight. Polymers of high molecular weight, जिस तरह PVC है. These are solids. However, these are non-crystalline solids. So, heterogeneous catalysts, they are solid in nature. और कौन से solid हैं वो crystalline in nature है. अब क्रिस्टलिनिटी कैसे डिटरमिन करेंगे, कैसे आइडेंटिफाई करेंगे, उसके लिए कैरेक्टराइजेशन टेक्निक यूज़ करते हैं. उसमें से एक है XRD. तो उसकी तरफ चलते हैं. उससे पहले ये ज़रा डिस्कस कर लेते हैं. अब एक टर्म यूज़ करते हैं क्रिस्टल लैटिस एंड यूनिट सेल. ये क्या है? इसके बारे में आप पहले भी पढ़ चुके होंगे. Crystal lattice and unit cell. What is crystal lattice? पहले crystal क्या है? What is crystal? Crystal is a homogeneous part of the solid substances. Homogeneous portion of solid substances in which the atoms or molecules are packed. In which atoms or molecules or ions are packed in such a way, packed closely in such a way that the potential energy is minimum. The total potential energy of the system is minimum. Crystal is a homogeneous portion of a solid substance in which the constituent particles, that is atoms, ions or molecules, they are packed closely together in such a way that the total potential energy is the minimum. That is called crystal. अब crystal lattice क्या है? Crystal lattice, जिसको space lattice भी कह सकते हैं, also called as space lattice. This is the highly ordered three-dimensional structure. It is a highly ordered three-dimensional structure formed by atoms, ions, or molecules. Formed by atoms, ions, or molecules. Crystal lattice is a highly ordered three-dimensional structure which is formed by arrangement of atoms, ions, or molecules. It can also be said that regular arrangement of constituent particles are regular arrangement of constituents particles in three-dimensional pattern in three dimensions. Is called lattice, crystal lattice, or space lattice. If the constituents of the crystals are represented by points, if atoms, ions, or molecules of crystals are represented by points, then this three-dimensional arrangement is called point lattice. Then the three-dimensional arrangement would be called as point lattice. अब ये पॉइंट होल एटम्स या होल पार्टिकल्स, होल मॉलिक्यूल्स और आयन को रिप्रेजेंट नहीं कर रहे हैं, बल्कि these points represent only the center of the constituents particles. अब थ्री डायमेंशनल का क्या मतलब? For example, if these points are arranged at regular interval along a line, a set of points repeated at regular interval along a line, then it is called a line one-dimensional lattice or line lattice. It is one-dimensional lattice. For example, इस तरह लाइन में अरेंज करते हैं, so this is one-dimensional lattice. इसी तरह अगर इन पॉइंट्स को हम अरेंज करते हैं in a plane, when set of points are repeated, points are repeated in a plane, regularly in a plane, regularly in a plane, then it is called two-dimensional lattice. इस तरह प्लेन में अरेंज करते हैं. Two-dimensional point lattice. 2D point lattice. If this two-dimensional point lattice is extended in three-dimensional, if 2D point lattice is extended in three dimensions, 3D, then it is called three-dimensional point lattice. 3D point lattice, and this is the crystal lattice. क्योंकि crystal lattice, that is the arrangement of points, that is atoms, ions, molecules in a three dimensions. So it is crystal lattice. That is called 3D point lattice or crystal lattice. इस तरह x axis, y and z, तो arrangement in three dimensions. इस तरह along z axis भी होंगे. और इस प्लेन में भी. So crystal lattice is the three-dimensional arrangement of the repetition of the constituents. यानी अगर अब इन पॉइंट्स को हम एटम्स, आयंस और मॉलिक्यूल से रिप्लेस करेंगे तो फिर इसको हम क्रिस्टल लैटिस कहेंगे. अब यूनिट सेल क्या है? ये तो हो गया क्रिस्टल लैटिस. क्रिस्टल लैटिस इज द regular arrangement of the constituents particles in a three dimensions. It is highly ordered three-dimensional structure formed by the atoms, ions and molecules. That is called crystal lattice. अब unit cell क्या मतलब? What is unit cell? If similar points are connected by parallel lines, if similar points in 3D arrangement of points are connected by parallel line, then the space lattice will be divided into a large number of small symmetrical units. These small symmetrical units are called unit cell. So these unit cell is the smallest building unit of the crystal. This unit cell is the smallest building units of the crystal. फॉर एग्जाम्पल हमारे पास है एक सिंपल ले लेते हैं अरेंजमेंट में. हमारे पास अगर 3 पॉइंट्स हो, इस तरह एक लाइन में 3 पॉइंट्स, यहाँ पर भी 3 पॉइंट्स। So this is a 3-dimensional arrangement of the point. अब अगर इन पॉइंट्स, इसको कहते हैं स्पेस लैटिस। इन पॉइंट्स को अगर हम रिप्लेस कर ले बाय एटम्स, आयंस और मॉलिक्यूल्स, देन इट वुड बी कॉल्ड एज क्रिस्टल लैटिस। अब इस क्रिस्टल लैटिस में या पॉइंट लैटिस में या स्पेस लैटिस में सिमिलर पॉइंट्स को अगर हम कनेक्ट कर ले थ्रू अ पैरेलल लाइंस, अब इसका सिमिलर पॉइंट्स ये हो गया और इसका सिमिलर पॉइंट ये हो गया। इस तरह ये दोनों और ये है, यहाँ पर भी पॉइंट्स बन जाएगा ना। इस तरह ये है, यहाँ पर ये कनेक्ट कर लेते हैं और ये इसके साथ कनेक्ट कर लेते हैं। अच्छा, ये इसके साथ कनेक्ट हो गया, ये इसके साथ कनेक्ट हो गया और ये इसके साथ कनेक्ट हो गया, और इस तरह ये वाली भी कनेक्ट कर लेते हैं। सारे पॉइंट्स को अगर हम कनेक्ट कर लेते हैं और ये यहाँ पर हो गया, ये सेंटर वाला, और इफ ऑल सिमिलर पॉइंट्स आर कनेक्टेड थ्रू पैरेलल लाइन, then the whole crystal lattice is divided into small units. Each unit is called a unit cell. तब यहाँ पर ये एक यूनिट सेल बन जाएगा ना, या ये ले लेते हैं, ये इस तरह एक यूनिट सेल, इसका स्मॉल यूनिट सेल बन जाएगा। स्मॉल तो ये एक यूनिट हो गया। This is called unit cell. If the similar points in a lattice are connected by parallel line, it is divided into small units. Each unit is called unit cell. This unit cell is characterized by definite length and angle. Unit cell is characterized by definite length and angles. तो इस लेंथ और एंगल के बेस पर देयर आर डिफरेंट टाइप्स ऑफ यूनिट सेल। तो जो लेंथ पैरेलल टू एक्स एक्सिस, इसको रिप्रेजेंट करते हैं ए से। इस तरह जो y एक्सिस है पैरेलल टू y एक्सिस, इट इज रिप्रेजेंटेड बाय b, और जो z एक्सिस है इट इज रिप्रेजेंटेड बाय c। सिमिलरली एंगल बिटवीन a and b, this is represented by gamma. Similarly, angle between A and C, it is represented by beta, and angle between B and C is represented by alpha. These are nomenclature of a unit cell. इस तरह ये x एक्सिस, ये y है और ये z है। जो x एक्सिस के साथ है वो a है, along y एक्सिस ये लेंथ b है, along z एक्सिस ये लेंथ c है. Angle between a and b, this is called gamma. This is gamma. Angle between a and c, this one is beta. And angle between b and c, this is alpha. इस तरह भी अगर हम यूनिट सेल ले लेते हैं, ये एक यूनिट सेल है, तो ये हो गया x एक्सिस, ये इसका y एक्सिस और ये इसका z एक्सिस है. तो ये लेंथ, दिस इज a, length along this one is b और ये है c. इस तरह a और b के दरमियान जो एंगल है, this angle is gamma. a और c, this is beta, और b और c, there is alpha. So on the basis of these length and angles, there are 7 types of the crystals. Brevis lattice जिसको कहते हैं, वो अब पहले पढ़ चुके हैं, उस पर हम नहीं जाते. अब यूनिट सेल, ये इसके भी डिफरेंट टाइप्स हैं. वो नेक्स्ट में कर लेते हैं.